Images in MATLAB are represented by 3D matrices. The reason we use 3D matrices to represent an image is because your computer uses only 3 color channels to produce all the colors you can see. The colors your computer uses are red, green, and blue, or RGB. By mixing these colors in different proportions, we can generate all the colors that are visible to the human eye. The colors range in intensity from 0 to 255, or exactly 256 different intensities. So here's an example of how you generate an image in MATLAB. First, let's create a matrix A that contains 0 and 255. I'm using 0 and 255 to represent the intensities that we want to look at. 0 is the lowest intensity, or basically there is no color there, and 255 is the highest intensity, meaning we'll have total red, total blue, or total green. So first we need to create a 3D matrix in order to generate an image. So again, we'll use the cat function in 3 dimensions, and I am going to concatenate A to itself 3 times. And here is our 3-layered 3D matrix. The first layer will be the red channel, the second layer is the green channel, and the third layer is a blue channel, hence RGB. But before we can image this 3D matrix, we need to turn B into an integer matrix, because the image function in MATLAB cannot take floating point decimals. It can only take UN8 integers. Okay, now if I type image of B, I get an image that's just a black square next to a white square. So the reason this happened is because if we look at our 3D matrix, we have zeros on the left and 255 on the right. So we had 0 intensity for all 3 colors, and when that's mixed together we get pure black. And when we get 255, or pure red, pure green, and pure blue mixed together, we get pure white. So for example, I can create a red square instead of a pure white square by simply changing the intensities that I'm mixing together. In this case, I'm going to change green and blue to 0 and leave red as 255. So I can do that by calling on the second and third layer and changing everything to 0. So notice in our new 3D matrix, we only have 255 in the first layer, or the red layer, and zeros in the green and blue layers. Now if I image B, I get a black square next to a red square. And you can play around with the mixing the colors to generate any color squares that you want. So for example, let me generate a random image and compare how closely related the different channels are to each other. So our red layer R, again, has to be integer, and we'll use the rand function to create a 3x3 matrix, but we have to multiply our rand matrix by 255, since rand only gives us values from 0 to 1. And we'll repeat this procedure to generate the green layer and the blue layer. Now that we have our RGB layers, we can create our random image using the concatenation function. And if I image our random image, what we get is a 3x3 pixel space with a bunch of different colors that's dependent on how our random intensities were mixed. Now we can look at how frequent we can compare these different channels using the histogram function that we learned about last week, except this time we're going to use a specific histogram function called image histogram. So if you type imhist of rand image ::1, we get a histogram with exactly 256 bins going from 0 to 255, and it shows how many times each intensity occurs in our red channel. In this case, because we only have a small sample, most intensities occurred 0 times and only 9 intensities occurred once. So all the bars are the same height. We can also display our image hist in matrix form if we set our image hist equal to a variable such as n. And here we generate 256 by 1 column array where the values represent the frequency of each intensity occurring. So we have 0 intensity here, 1 intensity, 2 intensity, 3 intensity, counting all the way down to 255. And as you can see, most of our intensities are 0, and then we have 1 intensity here for one of the pixels that had that red intensity. And we can repeat this with the green channel, except I'll call it a different variable. And again, I have to change the layer I'm looking at. Since our green channel is layer 2, I change our layer to 2. And again, I generate a 256 by 1 column array. To compare how closely related these two layers are, I simply have to find the square difference of the two layers, or the two image histograms. So if I take n subtract m squared, I get 16. This absolute sum is a relative comparison of how closely related two images are. The smaller the sum is, the closer the two images are related to each other. Thank you.